March 2019, paper 2, question 11. A manufacturer of chocolates is launching a new product in a novelty-shaped cardboard box. The box is a cuboid with a cuboid-shaped tunnel through it. The height of the box is 8 centimeters. The top of the box is a square of side 3x centimeters. The end of the tunnel is a square of side x centimeters. The volume of the box is 2000 centimeters cubed. So volume is 2000 centimeters cubed. Volume itself would be length times breadth times height, which is 3x times 3x times h minus this volume here, which is x times h, which is x squared h. So what you have there is 9x squared h minus x squared h, which means that you have 8x squared h is equal to 2000. You want to have h because what you're looking for is in part A, you have to show that the surface area A centimeters squared of the box is given by A is equal to 16x squared plus 4000 over x. So this is for 3 marks. There is no h in there, so you need to have h in terms of x. So that's why you're using the volume here to put h in terms of x. So this means that h is equal to 2000 over 8x squared, which is 250 over x squared. So that's h. You're looking for an expression for the surface area. The surface area is equal to, you have 4 sides which are 3x by h. So you have 4 of those. So you have 4 times 3x h. You have 4 times 3x h. And you also have in this tunnel, which has been cut out, a square tunnel all the way through this box, you have 4xh plus 4xh. You also have the area at the top and the area underneath. So this area at the top is 3x by 3x, which is 9x squared. The area underneath is also 9x squared. And the area that you're losing there, I'll maybe write that on the next line. So you also have the area at the top, 3x by 3x. And the area underneath again is plus 3x by 3x. This area you're losing at the top is x by x, which is x squared, and underneath you also have x squared. So that means you have minus 2x squared is taken out of that area. So what you have in total here is 12xh plus 4xh, which is 16xh. And over here you got 9x squared plus 9x squared minus 2x squared, which gives you 16x squared. Now here you need to bring in your expression for h. So when you bring that in, you're going to end up with, you bring your 16x squared to the front, 16x squared plus 16x, the h you want there is 250 over x squared. So what you have now is 16x squared plus 16 times 250 is 4,000. One of the x's cancels out in the denominator to leave you the x there. So that is the area. That's the required form for the area. That's for 3 marks. And part B, you're being asked, and this is for 6 marks, to minimize the cost of production, the surface area A of the box should be as small as possible. Find the minimum value of A. So you need to differentiate this. So differentiating this, dA by dx, you've got this area here. So you bring that to the front, is equal to 32x. This is x to the minus 1. So you bring that to the front, so that gives you minus 4,000. And you take 1 off the index, so that becomes x to the minus 2, which you leave in the denominator as x squared. And that is equal to 0 at minimum. You bring your 4,000 over x squared to the left, equate it to 32x, and then you bring your x squared to the right, which means that 32x cubed is equal to 4,000, which means that x is equal to 4,000 divided by 32, and you're going to take the cube root of the whole thing to find x. So the cube root of that will give you x. Cube root, put that on your calculator. Okay, so you put it in a bracket. Cube root inside the bracket. You have 4,000 divided by 32. You put that in, you're getting 5. So that means that x is equal to 5. And for your area, you go back to that area expression there, put in 5, and you're going to end up with 16 times 5 squared plus 4,000 divided by 5. So your area when x is 5 is equal to that. Put that in your calculator. 16 times 25 plus 4,000 divided by 5. And the minimum area you're getting there is 1,200 centimeters squared for your minimum area. That is for 6 marks. The first part is the harder bit, but the more marks are for the second part.